Points D, F, and C are collinear. What'd y'all get? D, F, and C. I could draw a straight line through them. False. That one was easy. Stop insulting our intelligence, Miss Tanton. Number 2, points D, G, and S are coplanar. Coplanar, same plane. D, G, and S. Do you even need a picture? No, because any 3 points in the universe are coplanar. So don't even look at the picture and accidentally confuse yourself. Yes, true, they are coplanar because any 3 points are coplanar. Now, any 3 points don't determine a plane, but any 3 points are coplanar. All right, line FE intersects plane A at point E. Whew. So do you see line FE? Where is it hitting plane A? When does it go from solid to dotted? It goes from solid to dotted right here. So that's where the line is hitting the plane. So we're going to go with true. Plane B contains points G and S, but not point E. I'm good with that. I'm getting a true there. Point E is in plane A. And those planes are parallel. So a point cannot be in plane A and plane B at the same time because the planes are parallel. Last one. Line FE and line SG are skew lines. Now line SG is not drawn, so let's draw that line. We just connect S to G. So our biggest question is, do those lines intersect? Yeah, they intersect at point S. Now, if lines intersect, they can't possibly be skew, because in the definition of skew, they're not allowed to intersect. So are these skew lines? False. They are not skew lines. They intersect. How'd you do on the warm-up? 100? False, true, 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 false. Good. I'm not sure if they're perpendicular or not. Actually, they don't look perpendicular, but they do intersect. Intersect and perpendicular are 2 different things, so be careful with that word. Let's check your Algebra Review 2 homework. You might have had lots of questions, and that is A-okay, because I can work those problems. Factoring, systems, multiplying binomials, foiling. All right, number 3. The first thing that you would do here is you would clean it up. It's like you just walked into your room and there was a huge mess and you've decided that you need to clean up the mess first, okay? So we are going to clean this up. All right, so if we want to clean our room up, first we're going to do some distributing. And then we're going to combine like terms, okay? So take that 3 and distribute it. So we have -5 plus 3x minus 6 equals 15. And a lot of you might have forgotten to distribute that -1. Do you see how there's an understood -1 there? The 1 is not written, but it's there. So you need to distribute that -1. So 15 minus 2x, and then when we bring it here, a -1 times a -4 is a +4. The negatives turn into a positive. So that could have messed up your whole problem. Now we're going to combine like terms. The 3x, there's no other x's here. So we're done. -5 and -6 become -11. Now we're going to clean it up over here. The -2x, there's no like terms, but 15 plus 4 gives us 19. Okay? Now I can move the 11 or I can move the 2x. I'm choosing to move the 2x. So we have 5x minus 11 equals 19. So now we can add our 11 to both sides. 5x equals 30. X is 6. Dun, 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 dun. Magic. Yes, you can do that right now. Yes. Ganesh, you can do that. Okay, what did y'all ask me about next? Number 4. Even though that wasn't assigned, I can still work number 4. Maybe it was intimidating because it had a fraction in it. Number 4, what I would do first is I would get rid of my fraction. I would multiply everything by 10. That way you're not dealing with a fraction and you're not having to add or subtract fractions, getting a common denominator. So the way you get rid of a fraction is you look at the denominator and you multiply everything by that number. So the denominator is 10, so 10 is the chosen one. So I'm going to multiply everything by 10. When I multiply 3/10 times 10, the 10's cancel, and I just get 3. The 10's cancel. 10 times 13, and then 10 times negative x. And then it's really simple from there. Add 10 to both sides. 13x equals 130. Divide by 13. X is 10. Okay? All right, number 5. Okay, remember, you're going to have a calculator. So you can just, the decimals should not scare you. We're just going to take our calculator and we're going to let him do all the hard work for us. So let's distribute that 4 to start with. 4 times 0.2 is 0.8x. 4 times 3.7, 14.8, 0.7x minus 6.7. So you don't treat this any differently than just plain old numbers. You're going to get all your x's on one side, and you're going to get all of your constants on the other side. I like to deal with positives, but it looks like we have no choice here. I'm going to get rid of this one. The opposite of positive 0.7 would be negative 0.7. So 0.8 minus 0.7, that would give us 0.1. And then I'm not going to move anything else yet, so I don't confuse you. Okay, now everything needs to move away from x, move away from x. So do the opposite of what's being done to it. So negative 6.7 plus 14.8. So 0.1x equals negative 21.5. And then our last step is to divide by 0.1 because the opposite of multiplying is dividing. So 21.5, negative 21.5 divided by 0.1. Wow, look at that. Is it negative? Yep, negative 215. Perfect. Negative 215. The calculator did the brunt of the work there. So looking at number 15, I immediately know that that's a quadratic because it has a squared in it. X squared. When we're dealing with quadratics, there are different ways to solve it, like the quadratic equation, but we're going to solve by factoring because that's what the directions said, okay? So when we see a quadratic, we know step number 1 is always to set it equal to 0. There's no surprises. That is always the first step. So 2x squared plus 5x minus 42 equals 0. And let me give you a little hint that might help you. Look at the leading coefficient. That's this number right here. If everything is divisible by that number, you can just divide that number out and get rid of it. Now in this problem, 5 unfortunately is not divisible by 2, so we can't get rid of the 2, but you need to always check for that because sometimes you can get rid of that leading coefficient, but not this time. So what we do is we set up our parentheses and we get ready to factor. All right, to get a 2x squared, we would multiply 2x times x. So we at least know that much, right? The next part is when we go off to the side and we have to experiment a little. We take our constant, our number, and we think about what the factors are of 42. So we've got 21 and 2. We've got 6 and 7. What else do we have? 3 and 14, 42 and 1, right? You list as many factors as you can think of. Here's where we have to kind of play a little bit of a game. You get to double one of these numbers, and somehow you need to make a 5 out of it. So you get to double one of those numbers, and somehow you need to make a 5 out of it. And I can see the answer right away. But if you can't see it right away, then you need to play with them. If I double 2, I get 4. Can I make a 5 out of a 21 and a 4? No, those are too far apart. And I know if I double 21, that's not going to help me at all. So that pair is now gone. Okay, let's try the next pair. If I double 6, I get 12. Can I make a 5 out of a 12 and a 7? Ding, 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 ding. I can make a 5 out of a 12 and a 7. So that pair is my winner. And I need to make sure what gets doubled, my 6 or my 7. To make sure my 6 gets doubled, because I need it to turn into a 12. So I'm going to put the 6 where it's definitely going to get doubled. And then I'm going to put his partner in crime, the 7, I'm going to put that in the other parenthesis. Now the only thing left is we need to decide who's positive and who's negative. So on this one, we need to make a positive 5. If I want a positive 5, would I do 7 minus 12 or 12 minus 7? I would want to do 12 minus 7. I want the bigger one to be positive. So I want to do 12 minus 7. Okay, the last step is always to set it equal to 0. Set both sets of parentheses equal to 0. So x plus 6 equals 0, and 2x minus 7 equals 0. Subtract 6 from both sides. X equals negative 6. This one is a two-step problem, so watch out. Add 7 to both sides. 2x equals 7. Divide by 2. X equals 7 halves. So the next one that y'all asked about was number 17. Number 17 is also a quadratic because it has the x squared, so be looking for that. If it has an x squared, it's going to have 2 answers because the degree is 2. Now the good news is they already set us up. It already equals 0, so that's one step that we don't even have to do. Sure, Edriel. So we start our parentheses. This one we are in luck because it does not have a leading coefficient. The leading coefficient is 1. So that is good news, okay? So now we can just take this last number and we go off to the side and we brainstorm things that multiply to get 48. So the way that you do that is you can go to your calculator and just start dividing 48 by things. So we've got 12 and 4. What else? 8 and 6. 24 and 2. Oops. Now, you can stop at any time and you can start playing with those numbers and see if you have a winner. So, let's see. We need to make a 14. We need to make a 14 by either combining, adding, or subtracting. Can I make a 14 out of a 12 and a 4? No. Can I make a 14 out of an 8 and a 6? Ding, 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 ding. I can make a 14 out of an 8 and a 6. So that pair is my winner. I stick the pair in the parentheses. And now I just need to decide my sign. I need a negative 14. So I would need both of these to be negative because negative 8 plus negative 6 is negative 14. Now, is that going to turn out okay when I'm looking for a positive 48? Well, sure, because when you multiply the negative 8 times the negative 6, the negatives cancel and you get your positive. All right? So, x minus 8 equals 0. and x minus 6 equals 0. Add 8 to both sides, x equals 8. Add 6 to both sides, x equals 6. And those are the two solutions to your problem. On the quiz, could you take those numbers and plug it back in with your calculator? Yes, you can and you should. 21, we are now into systems. This is not factoring anymore, this is systems. You have two options when you have systems. You've got elimination and you've got substitution. Now you're going to use substitution when a variable is kind of already by itself. But we don't have any variables by themselves. We've got our x's are all lined up and our y's are all lined up and our constants are all lined up. So we're definitely going to use elimination. Now the thing about elimination is you want one of your variables to cancel. You want it to be gone. And right now if I were to add these together, none of my variables would cancel out. But we know that if we can turn this into a negative 9y, then it'll cancel out with the 9y. So you have to think to yourself, what could I multiply this by to make sure that that negative 3 turns into a negative 9? Da-da-da. You would multiply it by 3. Okay, so make sure the biggest mistake people make is that they don't multiply every single thing by 3. They forget to multiply that last number by 3. So be careful there, okay? All right, so 8 times 3, 24x, 3 times negative 3, negative 9y, and 3 times 32, 96. Now we can add these together and solve by elimination. 24 plus 7, 31x, our y's cancel, and then we have 96 plus 28, 124. You know what to do now. Divide by 31. Final answer, x equals 4. We love when the answer turns out pretty, right? So now all we have to do is plug it back in, and you can plug it back into either equation. I'm going to plug it back into this first equation right here. So instead of x, I'm going to put 4. So 8 times 4 is 32. We don't know y yet, so we have to write that. Wait a minute, that's weird. Subtract 32 from both sides. Negative 3y equals 0. Divide by negative 3. 0 divided by negative 3. Okay, y is 0. So you put your answer as an ordered pair. X, comma, y. 4, comma, 0. Okay, and then the very last one I was asked about, I'm going to do it really quick. Number 19. Step 1, divide by 5. X squared equals 4. This is really important. Because there's an x squared, that means you're going to have two answers. So be really careful. You're going to have two answers. What's the opposite of squaring something? Square rooting, right? So we're going to square root both sides, but be careful, this is equal to plus or minus the square root of 4. So x is not just 2, it's plus or minus 2. Or you can put negative 2, comma, positive 2. So when you take the square root of something, you need to make sure you put both valid answers, because 2 squared is 4, and we all know that. But negative 2 squared is also 4, so don't leave that one out. We need to start on our lesson today. Segment addition and midpoint. If you want to get some notes out, if you want to take notes, you can. And if you want to just watch, you can totally do that as well. So first we're going to talk about how you would find the length of a segment on a number line. We're not talking about counting spaces with your finger. We're talking about mathematically calculating the distance from A to B on a number line. Remember, this means AB with nothing on top of it. It doesn't mean segment AB. It means you find the distance from A to B, the length of AB. So there are a couple of ways that you can do this, but I'm going to go ahead and just throw at you how to do it. We're not going to discover it this time because of our time. The way that you find the distance is you take the absolute value of the difference. Did you hear me? The absolute value of the difference. The absolute value of the difference. Now, what does difference mean? Difference means subtract. What does absolute value mean? Make it positive. So that's what I'm saying. Every single time, if you want to find the distance on a number line, you subtract and make it positive. Subtract and make it positive. The great news about this is that it doesn't matter which number you put first. It doesn't. So you can say 4 minus the other point, -5, or you could say -5 minus 4. Because no matter what, you're going to get 9 because you're going to make it positive. So you can't mess this up because it doesn't matter which one you put first because you're going to be making it positive. Cool? So the distance from A to B is 9. Now, could you just use common sense and say, this one is 5 away from 0, this one is 4 away from 0, so that's a total of 9. Can you do that? Sure. So that's up to you. All right. We have some popular people up here. It might be old. Sorry if they're old. Let's find the distance between Carrie Underwood and Drake. Good. Find the distance between Christian Bale and Jennifer Lawrence. What do y'all think? Very good, Victor. 22. So, remember, you could have just said, oh, Christian Bale is 14 away, and Jennifer Lawrence is 8 away, and so that's 22. Or you can take the absolute value of the difference. You can subtract and make it positive, subtract and make it positive, because that'll work every time. Subtract and make it positive. Okay, last one. The distance between Lady Gaga and Taylor Swift. Yes, 38. Subtract and make it positive. -1 minus 37 is -38, and then you make it positive. So in this class, we don't ever have negative lengths. We don't ever have negative distances. We've learned this before, congruent. Congruent segments are two segments with the same, good, length. Two segments with the same length. How do we indicate that they are congruent? What do we add to our picture? I call them tick marks. I call them tick marks. That now is me communicating to you that AB is the same length as BC. We have already gone over this, so I'm just reminding you that if I don't put any symbols, then those are measures, those are distance, those are numbers. But if I do use symbols, those are segments. They are congruent, okay? They're segments. So one of them is segment and the other one is a distance. Which one of those is incorrect? A, B, C, or D? Which one of those did people use incorrect notation? Hi, yo. B is the answer. You cannot say a number is congruent to a number. That does not work. You would need to put equals there. All of these are good. This is good, and this is good. The only one that was wrong was B. Okay? You can't say that a length, a distance, is congruent. Distances are equal. Okay, midpoint. This was on your vocab quiz. A midpoint is a point that, what does it do? What word goes there? Starts with a D. I'm going for a D word. You might use a different word. Yep, that divides a segment into two, and y'all said this already, congruent segments. So point B is the midpoint of segment AC. Since it's the midpoint, I now know that AB is congruent to BC. So a midpoint is a point exactly in the middle. The segments on either side should be congruent, should be the same length. Here's our last vocab word of today, and then we'll do practice problems. Segment addition. If 3 points A, B, and C are collinear, and B is between A and C, then blank plus blank equals blank. So this one is part plus part equals whole, and I bet you've heard that before. Okay, go ahead and go. So if I wanted to write a segment addition statement, that's what this is, a segment addition statement, I would say AB plus, good job, BC equals AC. You need to make sure that you start where you left off. Do you see how I ended with B and then I started with B? Segment addition means I am putting these two segments together to make a whole segment. Now, is B the midpoint? No. Is AB congruent to BC? No. But if I add this part plus this part, I'm going to get the whole thing. And that's what segment addition says. All right, we're going to go through every situation I could give you, and we're just going to talk about the strategy. Here's a situation I could give you. What is E? Give me a vocab word. What is E? Midpoint. Very good. So when I give you a midpoint, when these two segments are congruent, what are you going to do with those two values? Are you going to add them? No, good job. You're going to set them equal. And I don't even care about solving it. I just want to know what the strategy is. So when there's a midpoint, you can just put an equal sign on top of that midpoint. The two segments on either side are equal. Next one. Ooh. Is E still a midpoint? Yes. But did I give you a half and a half? No. I gave you a half and I gave you a whole. So be careful. On this one, you would not set 3x equal to 54. So you have two choices. And Johan, you said one of them. I could take 54 and I could cut it in half. 54, cut it in half. So I could set 3x equal to 27. Or what's the opposite of having something? Yes, it's recorded. Doubling it. Very good. So I could either take the whole and cut it in half, or I could take the half and I could double it. 6x equals 54. Do you see the two choices that we came up with? Either 3x equals 27 or 6x equals 54. This is a half equaling a half, and this is the whole equaling the whole. Last example, last situation I could give you. This time is E a midpoint? No, because if you don't see tick marks, then you are not allowed to assume that that is a midpoint. So do not assume. So this is the example where we would use part plus part equals whole. So on this one we would say part 3x plus part 26 equals whole 54. And we would solve it from there. So do you see the three situations? I gave you half and half, I gave you half and whole, and then I gave you part and part. And that is the lesson. Okay, we're just going to keep trying some, but if you need to go, you're welcome to go. DE is 3x, got that one. EF is x minus 6, got that one. And DF is 30. So we ask ourselves, what situation are we in? Are we in a midpoint situation or a part plus part equals whole situation? Definitely a part plus part equals whole. E is not the midpoint. So we set up an equation. Part plus part equals whole. Do you see why we took 2 days to stop and review algebra? Because you're going to have to do algebra to do geometry. Algebra is ingrained in the geometry. 4x minus 6 equals 30. Sorry about my 3. 4x equals 36. X equals 9. End of story, done. If I asked you to find DF, could you find DF? Sure you can. You just do like the Glade commercial. Plug it in, right? You take the 9 and you plug it in. Oh, well, DF is already 30. Sorry about that. I meant DE. DE. Take the 9 and plug it in. 3 times 9, 27. So once you find X, you can find any segment that you are asked to find. Okay, go ahead and see if you can solve this one. Okay, guys, here's where we have 2 options. I gave you a half and I gave you a whole. We talked about you can double the half or you can half the whole. Now, 27 is not divisible by 2, so I would not recommend that. Since M is the midpoint, I would add tick marks to my picture. Those are congruent. So AM is 2x plus 13, but so is MB. They're both 2x plus 13. So what equals 27? Well, how many x's do I have? I can double it. 4x, and then minus 13, minus 26. There we go. 4x minus 26 equals 27. 4x equals 53, right? What's wrong? And then we need to divide 53 by 4. And you get 53 fourths. Or if you want to write 13.25, you can write 13.25. Those are 2 different ways to write your answer. All right, that is my bell.